Welcome everyone to the session of Automating Cloud Course with Terraform. My name is Ruben Montero and I am the CTO of OpenNebula Systems. And for this session, we'll have the presence of three great speakers. First, we'll have Ned Bellavance, which is a HashiCorp ambassador. Then we have Jean-Philippe Foures from Iguane. And then we have Danny Abukalam from SoftIron. Welcome the three of you, and thanks to all the attendees for joining us today for this session. Remember that you at any time you can use the chat on this same page to send your questions. So in this session, we are going to talk about Terraform a lot and its relationship with cloud computing. As you probably know, Terraform is an open source infrastructure as code tool that enables the automation and management of cloud resources across different providers like Amazon, AWS, or OpenNebula. It allows in this way the user to create the desired infrastructure configuration in a declarative language. From the point of view of cloud computing and OpenNebula, we think that Terraform is really an essential asset for any organization leveraging cloud computing. Because first, it brings you the consistency and reproducibility to build your infrastructure. So you can, it really helps you to manage complex deployments. And second, with Terraform, you can plan your deployments in an agile and scalable way, as you can manage all these deployment things in a programmatically way. From the point of view of OpenNebula, we actually use Terraform in two different ways. On top of OpenNebula, you can use the OpenNebula Provider to create not only your virtual infrastructure. I'm thinking of the applications or virtual machines the networks that you create on top of OpenNebula, but also you can create some of the resources managed by OpenNebula. You can create hosts, or you can create users. A lot of the resources that are actually living in OpenNebula can be created and managed through the OpenNebula Provider. But we are not only using the Terraform tool on top of OpenNebula, but also underneath. The One Provision tool, which is part of the OpenNebula toolset, is responsible for creating edge clusters across different providers. Those clusters are provisioned using Terraform. So we create all the resources associated with your edge clusters, like instances, networking resources, firewalls, and so on, also with Terraform. OpenNebula also handles the Terraform state files, and those are kept in the OpenNebula database and are replicated across frontends if you are using an HA configuration. So that's a quick introduction of Terraform on OpenNebula, and now I will leave the floor now to Ned, so we can hear some news about the recent enhancement that Terraform is doing. So Ned, the floor is yours.
Hi, everybody. My name is Ned Bellavance, and welcome to my portion of the presentation. Today, I'm going to talk about Terraform in order to set the stage for some of the other presentations you're going to be seeing. We'll cover some of the basics of what Terraform is for anyone who isn't familiar, and then get into some exciting new improvements and features that have been added to Terraform since its 1.0 release. So let's get started. By way of introduction, like I said, I'm Ned Bellavance. I'm a HashiCorp ambassador, and I've been in that program for the last 3 years or so, and I've been working with Terraform itself since 2017 or around that time, so pretty early days. In order to kick this whole thing off, I wanted to start with a very fundamental question, which is, what is Terraform? I'm guessing a lot of you have heard of Terraform before, but what I'd like to do is put a little more formality around that and maybe, fill in some of the gaps you might have in terms of what Terraform is, what it's intended to do. Let's start with the core premise. What is the main purpose behind Terraform? Well, it's intended to automate the management of infrastructure. And I'm careful to not say deployment or creation of infrastructure, because it's really meant to manage the entire life cycle of infrastructure, from its creation to its maintenance to its eventual deletion when that environment is no longer needed. That's the core goal behind Terraform, is to automate the whole management process. And Terraform's not focused on a specific cloud or a specific service or data center or anything like that. It can work with basically any service that has an API available, and it does that through a superpower we'll talk about in a moment. So we have our infrastructure automated tool. It's targeted at any cloud and any data center. And the way that you express your infrastructure is through a declarative domain-specific language. You're defining your infrastructure with code, also known as infrastructure as code. At a high level, that's what Terraform is. So let's dig into some of the key components that make up Terraform. We'll pull out one specific component beyond that, which is the providers. But I'll start with the Terraform core binary. Like many other open source tools, Terraform ships as a single binary that's compiled for a particular architecture. The binary includes all of the logic and operations Terraform needs to function. But what's not included in the core binary is how to talk to the various services that are out there. The provider plugin is a separate binary, and it functions as the bridge between the core Terraform binary and the service that it wants to interact with. On one side, the plugin knows how to talk to the APIs that make up the platform or service, and on the other side, it abstracts those APIs into the core constructs Terraform is expecting to interact with, things like resources and data sources. The way all that information is expressed, as I mentioned before, is through infrastructure as code and in a declarative way, typically using the HashiCorp configuration language, which is HashiCorp's own domain-specific language. Within your HCL code, you express the infrastructure you want to deploy and manage. You'll leverage the provider plugins to deploy that infrastructure, but you also want to manage that infrastructure over time. And so Terraform needs to understand what infrastructure it's managing. It does that through state data. It's basically a record of everything you've defined in your configuration and how it maps to the target environment you're managing. That brings us to the last component of the core components, which of course is the target environment. This is the actual infrastructure that's being stood up on whatever platform you're currently using. An easy example is if you're using Microsoft Azure, and the target environment would typically be a subscription where you've created things like a resource group, a virtual network, and maybe some Azure virtual machines, etc. That's in the target environment. The state data is that mapping between what's in that environment and what Terraform's managing, and how it's defined in the HCL code. State data, it's pretty important. Okay, so those are the key components of Terraform and a brief overview of what Terraform is. Now I want to highlight some of the relatively recent advancements in Terraform. And the first thing is version 1.0 of Terraform. Like I said, I've been working with Terraform since about 2017. And up until June of 2021, Terraform was still technically not a 1.0 product. And that's because of the way HashiCorp considers a product to be 1.0 ready. In order to hit that major release, a product has to meet a whole bunch of different things in their checklist. And because of the huge popularity of Terraform pre 1.0, they had to be extra special careful that they were meeting all of the requirements, especially around stability of the product and consistency of its implementation. Now that they've hit 1.0, they've made a guarantee that there will be no breaking changes to any of the core components that we just saw until the next major release. They will add new features and issue bug fixes. There will be new things you can do, but the core of Terraform is not going to change fundamentally until potentially version 2.0 or later. In case you're wondering what the current version is, it's 1.5, and that was just released as part of the HashiDays EU event. So that's where we're at right now. What has been introduced? What new features have been rolled out? Well, one major improvement that they've made is the way that Terraform validates the data that's been provided to it, and it does that in a few different ways. One big feature was input variable validation. You could already check that the correct data type was submitted, so that's pretty easy, but now they've added a validation block to the input variable definition, where you create a condition to test for based off the value submitted. If it passes, awesome. If not, you can return a custom error message to the user saying, you gave me X, I was expecting Y. And you can repeat that condition block to test for multiple different conditions. Now, the problem with input variable validation is Terraform only has access to the value that was submitted and not any other values in the config. So another feature they've added is what's called precondition and postcondition blocks. The precondition block checks to make sure something is true before a resource is evaluated or created, and so it means you're testing assumptions. Are the assumptions that I have about the state of the universe before I create this object true? If they are, great, create the object. If they're not, stop here and issue an error so the user can figure out what's going on. Post conditions are a guarantee after the object has been created that certain things are now true. So you can test for pretty much whatever you want, and if it tests to true, Terraform is happy. If it tests to false, Terraform stops the deployment and says, this post condition failed, you need to rectify or mitigate what's going on there. Those are two quick examples of data validation. Another big thing that was just released in 1.5 is check blocks. Check blocks handle problems like drift configuration. A check block defines a condition and checks it every time Terraform plan is run, but it's not going to stop or error out the process. It's just going to report back the status of the check. So if you're running a scheduled Terraform plan on a regular basis to inspect for things like drift detection, you can use the check block to do that. That's everything under the data validation category. Hopping over to state management to see what's new in there. Previous versions of Terraform relied on imperative commands to manage your state, and that sort of broke the declarative model of Terraform, and also the idea that you can preview changes to state before they're executed. So in that vein, HashiCorp has added a number of features that make actions declarative and planned instead of imperative. Move blocks are a good example. If you want to change the address of a managed resource in your config, you can use a move block to set the current and new address of that resource, and Terraform will show you that change in the execution plan before it makes it. If you need to force the replacement of a resource, previously you'd use the taint command. That's been deprecated in favor of the replace flag for the plan and apply commands. Again, now you'll see the changes that will be made to your state data before they're actually made, and the changes that'll happen in the target environment during the plan phase. The last one is another new feature that's in 1.5, which is import blocks. People are pretty pumped about this one. Previously, you would use the Terraform import command to add an unmanaged resource to your state data, and then you'd have to add an entry to your configuration that matched the entry and state data. Now you can add an import block to your config that identifies the resource in the target environment and the address you want to use in your config, and then Terraform will add the object to state data and create the resource block for you in your configuration. And of course, you can preview the changes in the execution plan before state data or the config is altered. All of this is meant to make the management of Terraform and any changes to state data be done in a declarative way with execution plans. One other big area of enhancement, and this is going to lead us nicely into the next presenter, is enhancements with the provider plugins. HashiCorp has released a new version of the provider development framework that's an improvement of the V2 SDK that they previously had. And they've also released provider protocols versions 5 and 6. 6 in particular brings with it improvements like better schema management, improved data types, and validation. You get full access to all the native data types that are in Terraform, and it has expanded diagnostics to improve the information that's returned to the provider plugin itself. The goal is to simplify and streamline the development of provider plugins and make them more consistent across the board. So those are the recent advancements and enhancements with Terraform, and that's going to do it for me. Thank you so much for your time, and I'm going to hand this now over to the next presenter, who's going to talk about a provider that was created specifically for OpenNebula.
Many thanks for such a great presentation, Ned. Now it's time for some details about the OpenNebula provider, which is a great contribution from Iguane. I leave the floor now to Jean-Philippe to hear more details about this contribution.
So thank you for the introduction. I'm Jean-Philippe Chores from Iguane Solutions, and I will talk about the Terraform provider for OpenNebula. So first of all, who we are. Iguane Solutions was founded in 2000, very easy to retain. And we are IT infrastructure experts. In other words, we are experts in platform management from bare metal to cloud. So our domain of expertise are infrastructure, bare metal and cloud, virtualization and so on, GitOps to deploy everything with the GitOps methods, and obviously observability to have always an eye on everything from our systems to our customer systems. So why OpenNebula with us? I will go back 5 years in the past. In 2018, when I joined Iguane Solutions, I was hired to build a new team to work on the new way to present cloud to our customers, our own cloud. We used to VMware solution, and we decided to change for something else, more flexible, more simple, and less cost. So we needed 3 axes. We needed to industrialize. We needed to have something more with visualization, and we also needed to anticipate anything. So this new team I built has the objective to deploy OpenNebula at Iguane Solutions. And in 2018, we started with 1 zone and 10 servers. And today we have a federation of 2 zones with 40 servers, 30 customers, and more than 700 VMs running on our cloud without any issue, without any major issues, and at uptime a very satisfying, close to 100%. So why we are talking about Terraform now? In 2018, when I decided to deploy this new cloud, it was also a new way to deploy our virtualized infrastructure for our customers. And in 2018, I wanted to have the same tool our SREs and DevOps use to deploy our customers on the public cloud. And in that time, it was Terraform. Today, it's still Terraform the leader. And in 2018, it was already Terraform. So I wanted to be able to use Terraform to deploy VMs and all the virtual infrastructure on OpenNebula. It's the first way to standards. Actually, I wanted to use the same tool we used to deploy on AWS, GCP, and so on. So that's what. It's also more helpful. Thanks to that, we are able to use the same modules, and we are building modules on that. And it was also easy to recover anything via automation tools. So now I will go deeper on the provider history. So like I said, it starts 5 years ago. So in 2018, there was an existing provider. The provider was developed by BlackBerry teams. Unfortunately, the provider available in 2018, it was not working on the last OpenNebula release available at that time. It was the 5.6. The provider was built to work on 5.2. So first of all, I started to adapt the provider to fit the available OpenNebula version to deploy virtual resources on our cloud. And then we decided to work deeper on the Goka library. The Goka library, it's the library available with OpenNebula presenting Golang bindings. Why Golang? Because all providers in Terraform are developed in Golang. Terraform provides an SDK in Golang language. So we had to use the Golang language to develop the provider. It was not a problem because at Iguane Solutions, every tools are developed in Golang. So we are experts in Golang too. So in 2019, we decided to rework the Goka to have something more flexible, more usable, and to fit with also what we had in mind to develop new tools more than the provider around OpenNebula. So then after this work, good work actually, thanks Pierre, my colleague, OpenNebula integrate this Goka into one repository, meaning that this library is always maintained at up to last OpenNebula version. It follows any OpenNebula release, and it means that at every release of one, the Goka is still working, so as the provider. And in the same year, after working on the Goka, we redeveloped a new provider, completely new, based on this Goka, using the new logic. And so we released the first version of the provider on that day. The next year, OpenNebula asked us to make it official, meaning that it was added to the Terraform registry. And it was the first milestone for us, and we were very proud of that. And then between 2020 and 2022, we worked regularly on fixing bugs and adding some new features. And last year, we released the version 1.0 of the provider, meaning that we reached the first level of satisfaction for us, of stability of the provider, and we were covering every virtual resource managed on OpenNebula. And this year, in March, we also added the way to manage infrastructure resources. I mean, hosts, data stores, and clusters. So since it was official, the provider was downloaded more than 135,000 times since 2020. It means that it's usually used between 150 and 200 times a day by any users in the world. So thank you for that. And you can already flash the QR code to go to Terraform registry if you want. And last slide of the day. It's what's new since last year. So last year at OpenNebulaCon, we already presented the provider, if you were aware of that. And since last year, so like I said, we released the first version official, the V1 of the provider in September. This version was focused on any virtual resources managed on OpenNebula. So in V1, you were able to deploy any virtual resources on a cloud already deployed. And we also added very useful features about tagging resources, thanks to the Terraform SDK v2 and default tags. Adding a default tag on the provider configuration, it will spread all these default tags on any resources supporting tag, meaning that you don't have to use a tag each time at each resources. So it's simple. And since then, as new features, we added in the v1.1 host, cluster, and data store, meaning that you are able also to manage all the underlying infrastructure on your virtual, and you can manage every resources on OpenNebula now via Terraform. So you can also automate your cloud deployment, your virtual infrastructure deployment. It's crazy. And in the v.1, we also added the filtering, resourcing filtering by IDs to search easily, and also an EPAM section for network ranges to simplify and to make it easy managing network ranges. So I want to thank a lot all any contributors, and specifically Proton, for their important contribution to the provider. There are lots of them since 2018, and it's crazy, and it's using a lot. And we are more and more PRs. So thank you, everyone, and continue to make it better. And if you want to contribute, even if it's to fix the documentation, if it's to ask questions or ask something more visible on the coming roadmap, sorry. So flash also this QR code to go to the provider. So thank you, everyone, and have a nice day.
Many thanks again for the presentation, Jean-Philippe, and also many thanks for this awesome contribution to the community, which is the OpenNebula provider. And now, to end the session, we have Danny from SoftIron that is going to talk some more words about the use of Terraform and cloud computing in an OpenNebula. The floor is yours, Danny.
Hello, this is Danny Abukalam, and I'm from SoftIron, and I'm here to talk to you about the Terraform OpenNebula provider and how we're using it inside SoftIron for some of our projects. Terraform is pretty powerful. Those of you that aren't familiar with it, it's a declarative way to deploy and undeploy resources on any kind of remote infrastructure, most of the time cloud resources. And that's, I would say, the majority of people that are using Terraform are using it to manage cloud resources, but it also handles all sorts of other resources in a very useful way as well. It means that you can kind of take all of your declarative deployment stuff and put it all together in one place and run it. So what you're looking at here is the architecture of my documentation project. So this is a build website, which is statically generated by mkdocs. Those of you that don't know, mkdocs is this great static site generator, and we actually use a popular theme called mkdocs Material, which is this thing here. And this is a really powerful theme for mkdocs, which lets you build some really good-looking documentation, and it's used by a whole bunch of people all over the world. And so we've been using this to build our documentation site. Our documentation site looks something like this. So you get like kind of sidebar and search, and you just write some markdown, and it gets you build it, and it gets built into a page for people to use. So how do we deliver this? We have two VMs, a production VM and a staging VM. And these are running Nginx, which are running a certain deployment of the documentation. Prod is building master, and that gets published to kind of our main place that our customers will go to. And the staging will actually deploy multiple builds. And basically, every time you push a branch to the repo, this then builds a new build and pushes it to the staging virtual machine. So staging virtual machine can have 100,000 different builds, whereas the production VM will only ever have one VM. And this gives people the ability to preview their documentation website builds before they get merged. And that's all handled by Terraform, which is great. So I'm going to show you how that kind of works. This is the docs repo. Inside, so the infrastructure is all co-located with docs. So if you want to make a docs change, you can. But if you understand how the infrastructure comes together, you can also make a change to the infrastructure, and that's all inside this hidden infrastructure folder. So we've got some Ansible, some Terraform, some docs, and a small email script, and then nftest is a bash script which just simulates the pipeline. So I'll talk about the nftest script in a second, but first I'll show you how this comes together. So inside the Terraform folder, we have a few different files. Providers, it tells us kind of what the provider we're using is, in this case it's the OpenNebula one. I've got a production and staging Terraform files, and those are to represent the different production and staging virtual machines and any other related infrastructure. In this case, it's just a virtual machine. Stuff is where I put some of the other like security groups and some of the other things that I need. This also goes to show that you can name your Terraform files anything you want. As long as it ends in a .tf, then Terraform will use it. And then you've got your variables, which is where you declare the variables that you've used in your various Terraform files. And then you have this TF bars, which is where you actually set the variables that you want to use. And you'll notice here I've got two TF bars, one for my bash script and one for GitLab to use, the CI pipeline to use. So what do these look like? I'll just show you the production Terraform. This is just a virtual machine, which builds the production version of our documentation site. I've also got, I'll show you the providers as well. And this is just, it does two things. It says, well, it does three things. Here's the provider I'm using. It's using a HTTP backend. So it actually stores the state of the infrastructure on a HTTP server, which is how GitLab manages Terraform state. And then it's got some details that the OpenNebula provider needs, such as the endpoint and the username password. So that's the providers piece. And then you can see kind of stuff is where I've got my security groups. So I'm opening some firewall rules, and I've also got a cool resource which writes an Ansible inventory file out so that I can run Ansible right after my Terraform. And that ends up looking, it's basically just a little inventory file, and it's generated using this this kind of templated inventory file. So that's how that works. So what's the mtest script? So the mtest script is basically all of this Terraform is run automatically by our CI pipeline. And so this is a living, breathing thing. So I can't actually make changes to the infrastructure without impacting production environment. So if I want to add or make any changes to the infrastructure, before merging them, I want to preview them somehow. So I need a development environment, which is exactly like my production environment, which shows me kind of what this looks like. And so, so my production environment consists of a production and a staging VM. And I need a development environment that also builds a production and staging VM, but and with some very similar networking between them and very similar kind of DNS setup and SSL and all the weird and wonderful things it needs to work. And that will enable me to make changes, test them locally, simulate them, and then when I'm happy, I can merge them into the master branch, and all the infrastructure will change when I do that. So the mtest is just a little bash script. I'm going to go ahead and run it to give you kind of a view of how this works. So if I do an mtest deploy, you'll see that what this is going to do is a plan and then an apply of my Terraform scripts. The plan is basically just a way to look at the existing state of my infrastructure, in which case right now I have nothing, and then it will show me a diff. It's kind of like a dry run. It'll show me a diff of where I am today versus what the kind of state I want is. And then right after the plan, my script is going to run an apply. So it'll actually go ahead and deploy these the VM and the infrastructure that first the production VM and also the staging VM, so that I can test my changes to the infrastructure. And that's kind of this is a dual pipeline setup on GitLab with Terraform and OpenNebula. One thing to say is that actually the OpenNebula provider for the OpenNebula Terraform provider is actually really fast compared to other public cloud providers that I've used in the past. So that's a really good thing. And also, if you're interested, you can see what my CI file looks like. It's fairly straightforward. I have a number of different stages: check, plan, apply, configure, build, and deploy. There's a little spell check there as well. And so the check will do the formatting and validation to make sure Terraform's correct. The plan will do, like I said, the kind of the diff of the state. The apply will actually go ahead and make the changes. Configure here is actually to run some Ansible on top of the VMs to get it configured with Nginx and some of the other things I need to run the website. Yeah, it's fairly straightforward. So what does this actually look like in GitLab? I'll show you our GitLab environment. So this is what our CI pipelines look like. And you'll see those stages are relayed right here. And these are all kind of branches. So this is a branch that actually I've just pushed, and the CI is just fixed. So what this does is this actually just adds a GDPR consent notification to the website, so that we're compliant with GDPR when publishing this doc site publicly. So this is the master kind of production build at the moment. And because I've got this production and staging separation for my infrastructure, you can see we have a way of previewing this specific CI build instead of the master one. And so I can take this and I can go ahead and change the base URL to be the pipeline ID. This is just an internal DNS name that we have, and so you're going to see this monitoring page again, but you're going to see it with the cookie consent form as well. And if I reload this, you'll see that the cookie consent form has come up, and I can read more and I can accept it, and that's kind of how this staging. So once we're happy with this consent form, we can then merge that branch into master, and that will be live on our production thing. So that's how we're using the OpenNebula Terraform provider. It's a really good way to kind of multiple pipelines with GitLab. The GitLab integration is a bit complicated at first, but once you get your head around it, it's really powerful. We use lots of Terraform providers at SoftIron, including our own, but this is kind of how we're using the OpenNebula one, and I'm a fan, so thought I'd show you what it looks like. Thank you very much.
That was also a great presentation, Dan. Many thanks for joining us today. And also all the speakers that we have in this great session. To everyone in the audience, also thank you for joining us. I hope that you enjoyed the session and the great presentation from our speakers. And don't forget that you can send your comments, questions through the chat, and I hope you will see you in the next session. Thank you.